We're here to demonstrate how we sample for microplastics in the Thames River. We've sampled for microplastics in November and December of 2016, and we also sampled in July of 2018. So what we intend to do is sample for a number of years. The target is 5 years during the summer and the winter time to see the variations in microplastic abundances. We collect about 34 samples. They come from Mitchell all the way down to Lake St. Clair and Woodstock down to Lake St. Clair. Of the 34 samples, all of them contain microplastics, so not one of them is clean, if you want to think of it that way. The range is in somewhere in the hundreds per kilogram of dry weight sediment to 8,000 particles per kilogram of dry weight sediment. We categorize the microplastics into fibers, fragments, and films, as well as beads. And so far what we found, at least in the first sampling run, is that the majority of what we're seeing are fibers, and that's followed by fragments, and then just a minor amount of beads. And actually the one sample that contained the most beads is from this location at the forks of the Thames River. Fibers mainly come from a variety, mainly from clothing articles, go into the rivers or creeks, they get into the lakes, and they also get into the oceans. Fragments come from breakdown of larger plastic products, so anything like a ketchup bottle or a pail that we use that's made out of plastic. What you end up getting is breakdown of that plastic into smaller particles. So those are the fragments. Films can come from plastic bags, but you can also get fibers from plastic bags. They also break down into fibers. Beads come from personal care products like toothpastes, body washes, items like that. As you may know, they have now been banned, so no longer can product manufacturers produce products that contain microbeads. When we're talking about microplastics, what we're talking about is something that's less than 5 millimeters in size. Most of what we see when we're sampling sediment and separating it out, separating the grains, mineral grains from the plastic, what we find is the plastics are about 2 millimeters down to micron size. They're very, very small. The smallest organisms are ingesting microplastics. There have been many studies that show this in the scientific literature. Things like lugworms, for example, even crayfish in the Thames River. There has been a study that shows that there's plastic in the crayfish. So they're ingesting it. The small organisms ingest the microplastic, and eventually it can make its way up into the food chain. But the bigger concern is that if the microplastic is hurting the smaller organisms, those organisms will die and not produce a food source for animals higher up in the food chain. So basically, small organisms are really important because they're not going to be able to feed the larger levels of the food chain if they're destroyed by microplastics.